So the volume by slicing method. So case 1 is in the form of the disk. The case number 2 is watcher. For example, you have the graph. Let's see this way. And then you do the solid revolution, go over this way. And when you do the cross section, since this is the axis, the cross section going to be parallel, not parallel, the perpendicular to the axis of revolution. When you draw the figure like this, it will help you set up everything. The axis of revolution, the cross section perpendicular to the axis. And since the cross section lies on the y-axis, so this is the position y. If you see this as a position y, the cross section or the slice here will go up and down in the y direction. That means the interval of integration gonna be the interval of integration in y. Okay, gonna be y between the value, if we usually use c and d for the y, c, d here. And what do you need? You're gonna need the radius. Okay, radius. And number 2, the thickness. And when we secant the graph, we draw the diagram. And since the slice here is sitting on the y-axis, the thickness is gonna be dy for this case. Okay, for this case, then dy. And then when you find the radius, you find the thickness. And number 3, the volume gonna be the integral of the pi, the radius square, and then multiply by the thickness. And the thickness or the width, whatever you want to call, that is the either dx or dy. Okay, for this case, for this diagram, let us do, it's based on the y, so going to be dy. And the pi is the coefficient. You can leave it the way it is and treat it as a coefficient or constant multiple, the integration. The key piece is here is from identifying the r. And another way to consider the r is the height of the bar measured from the axis of revolution to the curve. Okay, so for this, you can see like the axis of revolution, and we do it from the point y to the curve, to the end of the curve there. So this is the radius. I'm gonna clean up the earlier one. Volume by slicing method. The first part what we did in the package is about this method. When you have the curve and you rotate about the axis of revolution and form the solid object. You find the volume by slicing technique. When you slice it or make a cut, you do it perpendicular to the axis of revolution, and then it forms one slice or one piece as the disc, the solid disc. To find the volume, we find the surface area, and then the area is 2 pi r square. I'm sorry. Hi, Alex. I'm so sorry. I'm glad that you could come to join the other one. So I will clean everything up next week. So I'm gonna back to over here. So when you form a disc, you find the volume by finding the area or the cross-sectional area. The cross-sectional area is pi r squared, and then multiply by the thickness, and it will form the volume of the disc. And for the second case, the watcher, in the case that you have, for example, you have the curve, about you have the two graphs, or at least 2 graphs, and the region bounded by 2 graphs, they form the area, like for example, like this diagram. and then you rotate about the axis. In this case, I'm gonna do, like, for example, go over this axis. If this is the axis, you do the slicing technique, it would be similar. I mean, there would be the same concept for any problem involving slicing technique. Once you know the axis of revolution, you do the cross section perpendicular to the axis of revolution. When you do the cross section on the axis, this is the horizontal line, or in the x-axis. So this position is position x, and you see the region bounded from point A to point B. The position x tells you the thickness or the width as delta x, which is dx. X is bounded by point A and point B, so the interval of integration is going to be x from A to B. The next part, when you rotate, let me form the rotation here. You're going to get another portion, the surrounding or wrap or go around the axis of revolution. And the middle part of the solid is empty. After you pull out one slice, it's going to be the portion that is missing in the middle. It will form two circles, the inner circle and the outer circle. Similar way that you're going to find the area, but the area going to be the area of the bigger circle subtracted by the area of the smaller circle, because the middle part is not included. So the area can be found by using the outer radius to find the area of the outer circle, subtracted by the area of the inner circle. Okay, or the R in. Okay, so then the cross-sectional area for this case gonna be pi of the outer radius square subtracted by pi of the inner radius square. When you form the volume, the formula to find the volume for the washer gonna be pi as a common coefficient, and then from point A to point B, because this case I indicate A and B as the bound of the x value, so lower limit, upper limit, and then the outer radius square subtracted by the inner radius square, and then multiplied by the thickness. This case is dx. So that's how you set up the problem. And then the rest of the process depends on the integrand. Okay.